Welcome to The Explainer. Today, we're cracking open the digital toolkit used by cybercriminals. We're not just going to look at malware, we're going to see how it actually behaves, how a tiny piece of code can kick off a massive digital heist.
This single idea is the absolute key to understanding modern cybersecurity. It's not really about what the malware is, it's about what it does. You have to think of a cyber attack less like a single virus and more like a planned military operation, with a whole suite of specialized tools for each specific job.
All right, so here's our game plan. We're going to start with Phase 1, the infiltration. Then we'll see how attackers lock down control in Phase 2. After that, we'll look at a really interesting strategic choice they have to make before diving into Phase 3, the mission itself. And finally, we'll put it all together and decode the entire attack pattern.
Okay, let's dive in. Every single cyber attack, and I mean everyone, no matter how fancy, starts with one simple step: getting inside the target system. This is the infiltration phase. It's all about getting that initial foothold. So, the most common tool for this job? It's the downloader. You can think of it like an advanced scout. Its only mission is to get past the gates, call home to the attacker's server, and then pull in the real malware. It's built to be small, simple, and totally disposable.
And this is exactly where looking at behavior becomes so critical. Security analysts aren't looking for a file name, they're looking for a pattern. For instance, when a program makes a system call to download a file and then milliseconds later makes another call to run that file, that is a massive red flag. It's the digital equivalent of seeing someone unlock a door and immediately wave someone else inside. Classic downloader behavior.
Now, a slightly sneakier cousin to the downloader is the launcher, or loader. Instead of reaching out to grab the payload from the internet, a launcher smuggles it in, already hidden inside itself. It tucks the malicious code away in some unexpected part of the file, just waiting for the right moment to unpack and unleash its cargo.
Okay, so the malware is in, but the mission isn't over. Oh no, it's just getting started. The attacker's next big priority is to make sure they can stay in and control that machine from anywhere in the world. They need to turn that tiny foothold into a secure, hidden base of operations.
And they do this by installing a backdoor. It is exactly what it sounds like, a secret entrance that completely bypasses all the normal security, letting them come and go whenever they want. And the really clever part? To stay hidden, they often disguise their communications to look like normal web traffic, just blending in with all your other internet activity.
And this is where you really see the kind of power a backdoor gives an attacker. We're not just talking about access anymore, we're talking about total control. They can mess with core system settings, create or delete files, and even see what windows you have open on your screen. It's basically like they're sitting right there at your keyboard.
Now, one of the most popular and, frankly, brilliant types of backdoors is reverse shell. See, normally, an attacker tries to connect into a victim's computer, but firewalls are really good at blocking those incoming connections. A reverse shell flips that whole script. It makes the infected machine call out to the attacker. And since most firewalls are totally fine with outgoing traffic, it's an incredibly smart way to sneak right past security.
And this whole thing happens completely silently in the background. The malware kicks off a hidden command prompt, connects it out to the attacker's server, and then makes absolutely sure the window is invisible to the user. And just like that, the attacker has a fully working command line on the victim's computer, all started from the inside out.
So, with that remote control locked down, the attacker hits a major fork in the road. What they do next depends entirely on the mission.
And the answer to this question really defines the rest of the operation, doesn't it? Are they building a massive army for a huge, widespread attack? Or are they acting more like a silent assassin, focusing all their efforts on one specific, high-value target?
This brings us to the two main strategies, the botnet versus the rat. A botnet is that army, thousands of infected zombie machines, all controlled at once to do things like launch massive denial-of-service attacks. A rat, on the other hand, a remote administration tool, that's the assassin's scalpel. It's used to control just one or maybe a few machines with surgical precision for things like spying or stealing very specific data.
All right, so now we've reached the final phase. The infiltration worked, control is established, the strategy is set. It is time to execute the mission and achieve the whole point of the attack.
A huge number of attacks really just boil down to one thing: theft. And what's the most valuable thing to steal online? Credentials. A credential stealer is malware that is purpose-built to get its hands on your usernames and passwords because, let's face it, those are the keys to your entire digital kingdom.
And the ways they do this are just brutally effective. The malware can try to just grab stored password information directly out of the computer's memory.
Or it can install a keylogger, which is a nasty little piece of code that just sits there, silently recording every single thing you type, just waiting for you to enter a password somewhere.
But you know, the most sophisticated attackers, they don't even want to run their own programs if they can help it. I mean, why risk getting caught when you can just force a program that the system already trusts to do your dirty work for you? This is where the whole game of deception gets really, really interesting.
The technique is called DL injection. A DLL is basically a shared toolkit of code that lots of different programs can use. With DLL injection, an attacker forces a totally legitimate program like your web browser to load their malicious toolkit. So now, from the operating system's point of view, all the malicious activity looks like it's coming from a trusted application.
So here's how they pull it off. The malware finds a target, right? Let's say your browser. It then basically slips a little note into the browser's memory that says, here's the address of some code I need you to run. Then it uses a specific Windows function to tap the browser on the shoulder and say, hey, go follow the instructions at this address. And the browser, just doing what it's told, follows the instructions and ends up running the attacker's code, completely unaware that it's just been hijacked.
It really is the ultimate act of deception. The malware itself isn't what's stealing your data. It's hiding inside a program you use and trust every day, and it's forcing that program to do the dirty work. It's the ultimate form of digital camouflage.
Okay, let's zoom out and pull all of these pieces together. We've been looking at a bunch of individual tools, but when you put them in order, they form a clear, logical attack pattern.
And this is the life cycle. It always starts with infiltration, then it moves to establishing control, a strategic choice gets made, and finally, the mission is executed. The big takeaway here is that by seeing malware not as a single event, but as this multi-stage operation, we have a much better chance of spotting and breaking the chain at any point along the way. And that really is the key thing to remember from all of this. Malware isn't magic. It's a set of tools and techniques all combined in a logical sequence. And by really understanding the how and the why behind these behaviors, we're in a much better position to anticipate and defend against whatever these attackers are going to think of next.